the observation that broke determinism. For centuries, determinism felt unbreakable, a promise that the universe followed strict rules where every effect had a precise cause and every future event was already written in the present. If you knew enough, calculated carefully enough, and measured accurately enough, nothing would surprise you. The universe appeared to be a machine, and machines do not improvise. To understand how determinism collapsed, we must return to a time when physics believed uncertainty was merely ignorance. Randomness was blamed on poor instruments. Chaos was blamed on complexity. The underlying belief remained firm. Reality itself was exact. If outcomes seemed unpredictable, it was because humans lacked information, not because the universe lacked certainty. This belief shaped science, philosophy, and culture. It promised control. It promised prediction. It suggested that free will was an illusion, and that the future was already decided by the past. Given complete knowledge of the present, nothing could unfold differently. The universe was seen as a perfect clockwork, ticking forward without deviation. That confidence began to erode quietly. Experiments probing the smallest scales did not behave as expected. Particles refused to settle into precise states. Measurements disturbed systems irreversibly. Outcomes varied even when conditions were carefully repeated. Something deeper than error was at work. At first, these variations were dismissed. Scientists assumed hidden factors were influencing results, unknown variables, unmeasured causes. There had to be something beneath the randomness. Determinism could not simply vanish. But as experiments grew more refined, the randomness remained. No amount of control removed it. Identical setups produced different outcomes. Probability replaced certainty at the deepest level. Nature was not concealing answers. It was offering distributions. The turning point came when observation itself was shown to matter. Measuring one property erased information about another. Precision in one dimension demanded uncertainty in another. Knowledge was no longer free. It came with enforced limits. This was not a failure of technology. It was a boundary written into reality. The universe did not allow complete information. It resisted being fully specified. Determinism began to crack under the weight of evidence. What emerged was not chaos, but a new structure. Outcomes were random individually, yet predictable collectively. Order survived, but certainty did not. The universe did not calculate a single future. It sampled many. This observation did more than adjust equations. It shattered a worldview. The future was no longer fixed. It was constrained, weighted, and probabilistic. And once determinism broke, nothing about causality, choice, or prediction could ever be viewed the same way again. Once determinism cracked, physics entered a deeply uncomfortable phase because the idea that the universe might not decide outcomes in advance threatened the very purpose of prediction itself. If identical causes could lead to different effects, then the classical promise of total foresight was gone. The universe was no longer a script being read. It was a process unfolding with genuine uncertainty built in. This became undeniable through repeated quantum experiments. Particles prepared in the same state, under the same conditions, produced different results when measured, not slightly different, fundamentally different. No refinement in preparation removed the spread. No hidden correction restored certainty. Probability was not a temporary placeholder. It was the final answer physics was allowed to give. The most disturbing discovery was that this randomness was not chaos. It was structured. Outcomes followed precise statistical laws. The probabilities were exact, repeatable, and universal. Physics could predict distributions with astonishing accuracy, yet could not predict a single specific result. The universe knew the odds, but not the outcome. This shattered the classical idea of causality. Cause no longer determined effect uniquely. It constrained it. The present did not select one future. It defined a range of possible futures, each weighted differently. Reality stopped choosing early. It delayed commitment until interaction forced resolution. Observation became central. To measure a system was to disturb it. To extract information was to change what could happen next. Knowledge was no longer passive. It was participatory. The act of looking became part of the experiment itself. This was not philosophical speculation. It was experimentally enforced. Measure position precisely, and momentum became uncertain. measure energy sharply, and time became blurred. Nature demanded trade-offs. Information came with cost. The universe refused full disclosure. What made this especially unsettling was that the limitation was not technological. No future device could overcome it. Perfect instruments would still fail. The restriction lived in the structure of reality itself. Determinism did not break because humans were clumsy. It broke because the universe was built that way. Attempts to restore certainty multiplied. Hidden variable theories, alternative interpretations, deeper layers beneath quantum mechanics. But experiments closed each door systematically. No local mechanism could explain the correlations. The randomness was not hiding somewhere else. It was fundamental. This forced a radical shift in perspective. Physics stopped asking what will happen. It asked what can happen, and with what likelihood. Prediction survived, but certainty did not. Control was replaced by constraint. The universe had not become lawless. It had revealed a different kind of law, one that governs probabilities rather than outcomes, one that allows freedom within limits, and one that forever ended the dream of a perfectly predictable future. This is where the conflict deepened from a scientific puzzle into a philosophical rupture, because once determinism failed at the smallest scales, it threatened to unravel every larger story built on certainty. If outcomes were not fixed in advance, then prediction became conditional. If prediction was conditional, then control was limited. And if control was limited, then the universe was not the clockwork humans had trusted for centuries. The most unsettling realization was that randomness did not come from complexity. It came from simplicity. Even the most isolated, carefully prepared quantum systems behaved unpredictably. No hidden turbulence, no unseen interference, just pure uncertainty emerging from fundamental rules. The universe was not noisy. It was indeterminate. This indeterminacy did not weaken physics. It sharpened it. Equations became more precise. Predictions became more accurate at the statistical level. Yet the price of this precision was humility. Physics could describe patterns perfectly while remaining silent about individual outcomes. Knowledge gained boundaries it could not cross. This created a strange duality. On one hand, the universe behaved with extraordinary regularity. On the other, it refused to commit to specifics. Every event unfolded within constraints, yet no event was guaranteed. Reality behaved like a game played with weighted dice, where the rules were strict, but the outcomes were never pre-selected. This challenged the meaning of cause itself. Cause no longer dictated effect. It shaped probability. The past influenced the future without fixing it. History became a set of conditions, not a command. The universe did not push events forward. It allowed them to emerge. Even more unsettling was the role of information. What you chose to measure mattered. Which questions you asked mattered. Different measurements revealed different realities. Not because reality changed its mind, but because it never held a single answer in the first place. Possibility existed before fact. This reframed the idea of randomness entirely. Quantum randomness was not ignorance waiting to be cured. It was irreducible, a fundamental feature of existence. The universe protected it fiercely. Every attempt to remove it failed. Every deeper probe confirmed it. At the same time, this randomness did not lead to chaos. Large systems still behaved predictably. Averages smoothed uncertainty. Structure emerged reliably. Determinism returned its scale, not because it was fundamental, but because probability compounded into stability. Order survived by statistics. This made determinism feel less broken and more misplaced. It worked where scale hid uncertainty. It failed where resolution exposed it. The universe was neither fully determined nor fully random. It occupied a narrow middle ground, where freedom and structure coexisted uneasily. Standing at this boundary, physics was forced to confront a final tension. If the future was not fixed, then something new was genuinely happening at every moment. Reality was not replaying a script. It was being written as it unfolded. And that realization changed the meaning of time, choice, and causality forever. The climax of the story is not that determinism failed, but that it failed in a precise, disciplined, and unavoidable way that left no room for negotiation. The universe did not collapse into chaos when certainty disappeared. It reorganized itself around probability. Outcomes were no longer fixed in advance, yet they were never lawless. Reality replaced inevitability with constraint, and in doing so revealed a deeper, more resilient order beneath expectation. Once this was accepted, the meaning of prediction changed permanently. Physics could no longer promise exact futures. It could only map possibility. The present stopped being a blueprint for a single outcome and became a boundary that shaped many futures at once. Nothing was guaranteed, yet nothing was arbitrary. Every event emerged from a structured field of likelihoods that the universe enforced with absolute consistency. This reframing resolved a long-standing tension. The universe was not broken because it allowed randomness. It was functional because it limited it. Too much determinism would freeze change. Too much randomness would dissolve structure. By allowing uncertainty only where it could be absorbed, reality achieved stability without rigidity. Freedom existed, but only within rules. Surprise was possible, but never unbounded. At large scales, this probabilistic foundation vanished into averages. Planets still followed predictable orbits. Chemistry remained reliable. Life remained stable. Determinism reappeared not as a fundamental truth, but as an emergent illusion created by scale. The universe looked predictable because uncertainty was diluted, not because it was absent. This realization reshaped how physics understood causality. Causes no longer commanded effects. They constrained them. The past influenced the future without dictating it. History set conditions, not outcomes. Reality advanced by resolving possibilities, not executing instructions. What broke determinism was not randomness alone. It was a discovery that the universe refuses to decide too early. It delays commitment until interaction forces resolution. Nothing happens until it must, and when it does, the outcome is chosen from what was allowed, not from what was demanded. The observation that broke determinism did not weaken science. It completed it by showing that certainty was never the goal. Consistency was, and the universe achieved that consistency not by fixing the future, but by governing possibility itself. The